Okay, so today we're going to be talking about Unit 3 for Math 2, which is geometry. It's going to be really easy today. Go ahead and get your notebooks out. Basically today is just going to be definitions. So what we're going to be going through today, is point, line, plane, angle, circle, perpendicular, parallel, line segment, segment addition, angle addition, and midpoint formula. If you're curious on why we're doing this, as part of our standards, it's G.co.1, which you can find on my website. You can look at all the different standards and what we're going to be doing. And by the end of the day, you should be able to define geometry terms. So let's get started. The first term on our list is point. And I know that you're going to know half of these from middle school, which is fantastic. But point, let's get a definition. A point is a single X and Y that mark location on a coordinate plane. And plane we will define in a minute. I'll let you write that down. A point is a single X and Y that mark location on a coordinate plane. So let's get an example. Okay, so just like in the alphabet, X comes before Y, so does it come on our point. So it goes X and then Y. And of course this is our X-axis and our Y-axis. And let's say we have the point 3, 4. Okay? Well, since 3 is our X, we're going to start on the X-axis. And this direction is positive, this direction is negative with the X-axis. So if we're at a positive 3, we're going to go right 1, 2, 3 from the origin and go up. Since Y is 4, and for the Y-axis, up is positive and down is negative, we're going to go right 3 and up 1, 2, 3, 4. Not exactly perfect. Let's do it. So right there is point 3, 4. That will be the location for point 3, 4. And I know you know how to do this, but we're just reviewing. So let you write that down. And we'll erase point off of our things to do. Okay. If you didn't get it, you can pause the video. Let's go with line, which is our next term to know. And remember these terms, if you write the definition down on a piece of white paper, like a little poster, you can go on our vocab wall, which is 2 points per poster. So, it's always good extra credit. Line. A line is an infinite number of X. An even number of points.
Could you come to the office, please? Marvin, please come to the office.
Sorry. It's an infinite number of points that extend forever according to the equation and I hope some of you already know this, y equals mx plus b. And by some of you, I mean all of you. You should all know y equals mx plus b. Okay. So, once again, we're going to go back to our grid, because if it's an infinite number of points, and points mark position on an xy coordinate plane, then we need a coordinate plane. Okay? Once again, we'll label our axes as X and Y. Terrible X. And let's say we have the line right here. Y equals 2x minus 1. In our equation, y equals mx plus b. B is our y-intercept. M is our slope. Well, you gotta know what those terms mean. Well, y-intercept is where our line is going to cross the y-axis. It's where it's going to where the line intercepts the y-axis. So, looking at our equation here, that's where we're going to start. Is at our y-intercept, which is in this case -1. And if it's on the y-axis, we said that negative meant go down. We're going to go down 1 on the dot. So we're starting at our y-intercept of -1. Now we have to deal with the slope thing. What is slope? Well, slope is rise over run. So how far we're going up or down over how far we're going left or right. And in this case, our slope is 2. Well, that's just one number. It's not a fraction. So what are we going to do? Well, every number is a fraction. And if it's a 2, it's 2 over 1. Every number is over 1. So we start at our y-intercept, and we do our rise over run from our starting point, which is our intercept. And we keep saying that over and over again. So we're going to rise 2. We go up 1, 2, and we run 1 because we're 2 over 1. 2 over 1. Both positive, so I'll go up and to the right and make another dot. Now from there, I'll do the same thing. Rise 2, run 1, put another dot. And this continues how far? Infinitely. And extends forever. This should be extends. Now, do I only have to go in that direction? No, I can go the opposite direction. Well, to keep with our slope here, we're going to go down 2 and over 1 this way. And if I could do that correctly, when I connected them, it would be a perfectly straight line. And there is your line. Beautiful. Okay? Moving on, real quick. Okay, we're going to talk about planes and not the kind that fly around. A plane represents an area of space in a specific direction. So if we have our grid, this is a coordinate plane, right? That's where the term comes from. This technically consists of two planes, the x-plane and the y-plane. What is the direction for the x-plane? Well, if I told you where is x equals 4, you would go to the right 4. So now we're moving to the right. If I asked you what is x equals -5, you would move to the left 5. So x's specific direction, the plane of x, is left and right. Easy enough. And since you're all geniuses and you know that the other directions are up and down, that must be attached to what? The y. I know we got a lot of arrows going crazy, but there you go. Beautiful. Once again, you can pause the video or write that down, but I gotta go. Next up is an angle. An angle. Is, we'll say, ratio of vertical and horizontal directions measured by what? How do you measure an angle? Degrees. For now. We'll get to radians. Right now we're degrees. So I have an angle, and it's telling me a vertical and horizontal direction, right? They don't have to be perfectly vertical or perfectly horizontal, but pretty close. Because it's got to be less than 180 degrees. So I measure this in degrees, and you know all this stuff about angles, but at a perfect right angle is what degrees? 90. Good, 90 degrees. If it is a straight line, to measure that angle is 180 degrees, which makes sense because it's 90 is half of 180, which will be halfway around. And now let's say what the measure of our given angle is. Well, it's more than 90, so, and it's less than 180, and I'm not pulling a protractor out, but we will say that it's close to 110 degrees. Easy enough. What would the name of this angle be? It would be obtuse. So you have obtuse, acute, and right. Right is 90 degrees. Acute is less than 90 degrees. And obtuse is greater than 90 degrees. That's percent. 90 degrees. There you go. That's all we're going to do with angles right now. For the time being. Okay? Trying to see if I can pause this video. Okay, now we're talking about angles. And while we're talking about lines and lines, we'll talk about line segments. You know what a line segment is? A line segment is a piece of what? Of a line. With a definite start, I guess I need to put starting and stopping points. Starting and stopping point. Alrighty. So if a line goes on forever, a line segment is a piece of that line that goes on forever. Easy enough. And if it has a definite starting and stopping point, then the arrows do not keep going. It is just that guy. Perfect. On the topic of lines, let's talk about parallel and perpendicular. Parallel, two lines, this is going to be real easy, with the same slope. So if I have my lines on my grid, and I have y equals 2x and y equals 2x plus 2. Let's graph those. What's the y-intercept of my first one? Well, there's nothing there, so it's 0. And 2x is really 2 over 1. So let's rise 2 and run 1. Rise 2 and run 1. Opposite direction, down 2 over 1. And down 2 over 1. That's pretty close. So there's line 1. Let's graph line 2. My y-intercept is 2, so let's start there. And my slope is the same, 2 over 1. Notice that they are the same. I'm going to try and circle that. So now I rise 2, run 1. down 2 over 1, down 2 over 1, and down 2 over 1. Will they, and the key thing is they will never touch. They will never touch. All right? Going to perpendicular.